Hello. Hey, hello. Hi, everyone. Good morning.
Yeah, hi. Good morning.
Hey, hi, Banu. Good morning.
Morning. So I think Malli Reddy is the one who newly joined.
Yes.
Okay. You start from today?
Yeah.
Sorry, I lost you actually. Your voice is breaking. So Narendra, we have one more guy called Narendra. I think he's also joining from today, right? Hello, Narendra.
Hi, sir. Good morning.
Hi. Good morning. So you are coming from today, or you attended previous class?
I attended 3 days class.
Okay. Okay. You attended previous class as well. Okay. Okay, then Malli Reddy is the one who is attending from today. Okay. Then Vinay Arakota, I think you are also attending. I hope you also attended previous class, right? Hello, Vinay. You can chat. Actually, I'm not able to listen your voice. You can chat here if you are not able to speak. Oh, excuse me. Okay. Okay, fine. I got you. Okay, guys. So, shall we quickly revise the what we have gone through in previous class? So, can someone tell the what is the instance?
It's a
combination of data structures and
memory.
background data.
The memory structures and background.
Background process, right? Correct. So, what is the major components of instance? What are all things we'll be having in instance?
Shared pool, Java pool.
Yes, PGA
Yeah,
and
PGA and SGA.
yeah, that's the correct answer. So, when I ask, can you deeply describe about the SGA? Then, what are all components is there?
SGA having shared pool.
Java pool.
Okay.
Database user cache.
Buffer
Shared
cache,
pool,
Buffer cache.
large
Redo log
pool,
buffer.
redo log buffer. Perfect. Okay.
Stream pool.
flashback buffer,
Right. Perfect. So, what are some background process we have?
SMON, PMON, CKPT, and DBWN.
Right.
Archive writer, log writer.
Right. Perfect. So let me share my screen. We'll go through some other topics today. So I've sent in on this document to you. Have you guys gone through it?
Yes, sir. We got it.
So do you have any doubts? Anyone try to understood what it is? Okay. Okay. Since we have gone through this, I'm moving forward. So when I say database server, we will be having the database instance and along with database. Okay. Database instance will maintains the database. So when I said database instance, it's a combination of SGA and PGA and some background process, right? So and when I come to the SGA, these are the few major components in this. Shared pool is one of the main component. A flashback buffer is the optional one. And DB buffer cache is the main component again. Redo log buffer and large pool. So when I go to large pool, it's a stream pool, Java pool. Those are the few components in it. So basically what buffer cache is used for. So it will take the data from user and load it to the database. When user fetch, you're able to see my screen, right?
Yes, sir.
Okay, fine. So when user requests the read request, it will fetch the data. It will load the data from database to buffer cache. Then it will give to the user. That's the importance of buffer cache. And shared pool, uh, we will be having the library cache and data dictionary cache, where it will store previously executed queries, so that it no need to perform to database, or it no need to load the data from database again if we execute the same query again and again. Those are things we will be having in shared pool. Okay, when I come to the large pool, there we will be having a lot of kind of sorting purpose. So if there is any sorting operations, everything will be happening in large pool. And redo log buffer, it will contains the committed and uncommitted data, and it will load this. It will read this data to online redo log files. Later, those online redo log files can be backed up as a archive log files. This is the main process of and components of SGA. Okay, so I think you please go through this for better understanding. So since it's a theory, I'm just explaining the highlights, what it's going to do. Okay, then coming to the PGA. So PGA stands for
Program Global Area.
Program Global Area, Process Global Area, right? So it's okay. Before to this, I'll just show you. Okay, what is this? So yesterday I've explained this one, right? So this is called user. User will request one request. So the request will come through the PGA. Then it will go to the instance. Then it will communicate with the database. Then it will load. So here, can anyone tell? Suppose user 2 is connecting to the database. What would be the process? Again, it remains the same. User 2 needs to connect to the instance. So one separate PGA will be allocated to that user. So this PGA won't be shared with user. The separate PGA, the separate program global area will be assigned to the different user, whoever connecting to the next. But whereas SGA is a shared component. SGA is a shared component. So everyone can access the only one single SGA, but PGA will be allocating to the multiple users. Again, there are two type of PGAs. One is dedicated and another one is shared. When I say dedicated, suppose I have the database called production. I have 5 to 6 users in this. So all 6 users are connecting to the production database, and 6 PGAs will be allocating them in the form of server process. Okay. But I have a production called railway database. The users wants to connect to the users wants to book the tickets or update the tickets, whatever it is. Okay. But it is very difficult. Lot of almost huge number of clients would be trying to connect to the railways database. Let's assume, okay. But at that time, in such a case, it is very difficult to assign individual PGAs, right? We cannot estimate, we cannot calculate how many number of clients will be connecting to the database. In such scenarios, we will make PGAs as a shareable. Okay, we will make PGAs as a shareable. See here. Here I have the database. Let's assume my mouse where I'm having here we have the database. User 1 is connecting to the database, then one separate PGA is allocating to them. User 2 is connecting to the database, again one separate PGA is allocating to them. But SGA remains constant. SGA remains constant. Okay. Now let's see what and all things we will be having the PGA. It's a very little components we have to concentrate on. The main thing we will be having is user global area. In PGA, we will having the user global area. What is user global area? It contains three components: SQL work area, session memory, and private SQL area. Okay, just focus on the things. I'll show you everything practically, how this works and everything. Now let's try to understand what it is. Okay, SQL work area is where all your SQL operations. We need some space, right? Whenever we are giving select star from employee or select star from some table, it needs some space to load all the data. Okay, right? This is where that loading will happen. SQL work area it is. Session memory. Suppose session memory. Okay, suppose we have any bind variables. When I say bind variables, suppose select star from EMP. I'll use the where condition now. I'll use a where condition, and I'll pass one variable in where condition. Those information and this UGA needs to hold that particular variable in entire process of results until the user gets the results. It needs to maintain that particular where conditions, right, or that particular variables, right? Those variables will be stored under session memory. Private SQL area. Okay, private SQL area. When I say private SQL area, we have any order by clause or any sorting operations. Everything will be that will use this particular private SQL area. So this is the main components of UGA. And apart from this, we will be having the bitmap merge area. It will use to combine the results. Suppose I have multiple SQL queries in a single query. We will call as a nested queries, right? So in those kind of scenarios, this bitmap merge area will be useful. In the same way, we have hash area, stack space, that is just for some other useful purpose. Okay, now here if we go, I have explained what are the things here. I request you to please go through this theoretically. Then we'll talk about the background process. Sorry. So when I say background process, can anyone tell for which purpose I need a background process in my laptop or system? So if I open Task Manager, okay, in Windows I'm talking. In Windows I'm talking, but everything we will be practicing in Linux, okay? I request you guys to go some Linux things, but anyways, I'll be providing the basic Linux commands which are useful for our DBAs, okay?
Yes, sir.
Okay, so it's a just one line, single 2-3 words of commands. That's all. It's not a very big queries or commands. So in Windows, when I open the Task Manager, or when I go to the services, so here I'm having the lot of services here, right?
Yes, sir.
I'm having the ARSV that is stopped. So something is running here. Something AES service is running here. So a lot of things, audio endpoint. So we can see the lot of services. In Linux term, we call it as a background process. We call it as a background process. And those can be seen from the OS level. Those can be seen from the OS level. So we have some some purpose which this background is handling. This background process is handling. Suppose when I say when I say IBMP SV, it might be having the Lenovo this. It's a background process which is related to this particular laptop, right? When I open some application, when I open Google Chrome or something like that, see Google Chrome, one background process is running, which is related to my browser, Google Chrome browser. Okay, when I say Adobe, some particular background process will be allocating them, right? In general, the background process will maintains the entire thing. Suppose if we are running one application or anything, one background process will be allocating in the OS level. That process will maintains that runtime. Agree with me?
Yes, sir.
So similarly, when we open the database or when we start the instance, there are few background process will be allocating. There are few background processes there which will be having their own purpose. Let's talk about this mandatory process. What are some mandatory background process will be starting when we start the instance? We have discussed about the PMON, right? So what it stands for? Process monitor, right? We have discussed about the SMON. SMON stands for system monitor. And what is this responsibility? This responsibility is to recover the database or instance whenever it crashes abnormally. Whenever it crashes abnormally. What's the responsible of PMON? Is a process monitor. It will monitor all the
background process.
process. If anything is go down, it's a responsible to bring up. So similarly, we have talked about the DB writer. What it's do? It will communicate with the DB buffer cache and data files. It will load from the DB buffer cache and load into the data files, and vice versa. It will load from the data files and load it to the DB buffer cache. And we have one more called CKPT, which stands for checkpoint. So whenever user commits the data or something, user commits the transaction, one checkpoint will be generating. Okay. So RICO, there is one more background process is called RICO. Which is used for recovery, which is useful in the recovery purpose. And we have one more thing called log writer, LG, which stands for which is responsible to load the data from redo log buffer cache to online redo log files. So I'll show you basically how the Linux will be looking. Give me a minute. So this is a putty where we will be connecting to the database. Okay, I'll just try to fetch the IP address. Okay. IP address got changed. Let me restart this thing. These are the softwares we'll be going to install in our local PCs for the practice purpose. So I've installed the Oracle VirtualBox here. where in Oracle VirtualBox, I've installed the Linux for the practice. So this is how Oracle VirtualBox looks. Okay, let it be. Let it be start. Put my database in archive mode. Okay, I can be open the database with or without archive mode enabled. But suppose if I put my database in archive mode, this background process will start. Am I able to audible clearly? Are any disturbance? Hello? Can anyone tell am I audible clearly?
Yes, sir. It's
Yeah.
clear.
Okay. Because resource utilization is getting high, right, in my laptop. So that's why sometimes voice crunch will be there. Okay, I think it started. Right, 1, 2, 3. So my database is locating in somewhere. I'm connecting to that particular database remotely, right? So for connecting purpose, I'm using one software called Putty. So in real time, we use the Putty to connect our database servers. We doesn't know where that servers locates, right? That can be either in Dallas or US or UK, wherever in remote location, the servers will be there. But we have to connect to them in order of managing the database. Okay, are you guys seeing it, my screen?
Yes, sir.
Yeah.
So no database running in my server. I'll do and I'll start up one database to show the background process for you. I think the SID Oracle SID I've exported as a dev. I'll connect to SQL Plus. This is how we connect to the database as a DBAs. This is how DBA will use. This is the command to connect to the database for the DBAs. SQL Plus / DBA. But anyways, I'll be explaining this later. The main goal here is to show the background process. Okay. It's taking time. So it is connected to the ideal instance, which means the instance not yet started. which means the instance not yet started. So seeing Oracle. Okay, I've opened the one more session. Now here I'll give ps-ef is the command to see the background process in the Linux. ps-ef. PS stands for process state. Okay, and ef are the few extra options, and we are filtering them. Okay, script-i. Yeah. So I think no background process is related to dev database. Have you seen this is kind of network dev? There is something called Ora dev, or some listener is running on this. Apart from this, nothing is running, right? Now see, I will start the database. Now you guys will know the background process. Start the database. A simple command, a simple query is startup. That's all. So how many of you from Bangalore?
Myself, Banu.
Okay, who is
Like,
this?
I was in Bangalore, but
Okay,
basically I'm not from Bangalore.
Krishna. And
I
Manish.
was in Bangalore.
Okay, Narendra in Bangalore.
Yeah.
Shivnaik.
I am from Vizag.
Okay, Vinay.
Here also Vizag, sir.
Vinay also
Malli-
is.
Yes, sir.
Malli
Vinay
from
Okay, okay. The reason why I'm asking is, so you guys can up to the institute or office for the practice purpose, and there you can sit for at least 3 hours, okay, for a week,
Yes, sir.
so that we'll be interacting and we can discuss the more doubts over there, okay? That's the reason I'm asking. If everyone is Bangalore, I was supposed to ask you come to the institute one day in a week. That can be either on Saturday, something like that. Okay, okay, let's discuss this later. Our database is started. Our database is started. Select name, comma, open underscore more from $3 database. Dev is available, read write. I'll go to the next session. So I give the same command, okay? I'll give the save command. Now you see the difference. Lot of background process are started, right? Are you seeing the pmon here?
Yes, sir.
M1, M-man. Okay. Similarly, we will be having the S-man, CKPT,
Nico.
log writer, DBW0 means DB writer 0. And there is a archiver process. Okay. And there are some different kind of background processes as well, right? So if anything goes down, we cannot connect to the database, because we can always connect to the database when the instance is up and running. How can we say instance is up and running? If these all background processes are running. If anything goes down, we cannot connect to the database. Now you understood the importance of background process. So suppose they gave me one server and to check which and all databases are running for it. You simply go ps-ef, that is ps-ef to monitor the process. I'm filtering it. I don't want to see these many things. So I'm using the grep command filter to pass the string. Okay, grep fni. So it will ignore all k-sense. I'll just give the daemon. So it filtered. Okay, it result us about the background process which is having the word called pmon. So there is only one database is running my server. That database is name is called dev. This is how we can see how many databases or what and all databases are running in the server. Okay, let's go back to our topic. So do you understand what is this background process? How can we see them?
Yes, sir.
Any queries or any doubts over there? So I have explained the each and every background process. I mean, though full of abbreviations, process manager process for the PMAN. Okay, LRAG for listener registration, system monitor process for the SMAN, DB writer, checkpoint. So I've given the abbreviations for them. You please go through it. Okay. Then coming to our SGA part again. So we have something called a shared pool. I told you which is important for interview questions and all, right? So what are the things we will be having in the shared pool? The main thing is we will be having the library cache and data dictionary cache. These are the two main components interviewer will expect to answer: library cache and data dictionary cache. What is library cache? So suppose when I pass some queries against the database, when I run the queries against database, suppose select star from employee table or select star from some other tables, the query itself will store in the library cache. The query itself will store in the library cache. What do you mean by library in general terms? Basically, it's a collection of some things, right? If we have a books, we can call it as a book library. If we have a collection of mobile, we can call it as a mobile library. We suppose if we have a lot of huge laptops in a store, we call it as a laptop library, something like that, right?
Yes, sir.
So in database, library means all executed queries will store. Already executed queries will be stored in library cache. Why it will be storing? Suppose when you execute the same query next time, it no need to pass through all the steps which database will be generally having. So it will directly fetch. If already that particular query is present in the library cache, it will fetch the details from here itself and it will give it to the user. And it will bypass the next other process. Similar way, we have the another component is called data dictionary cache. Okay. What is a data dictionary? When I say data dictionary, this data is available that particular table. This data is available that particular index. Those kind of navigations it will be having. Those kind of information the data dictionary is having. Okay, data dictionary stores information about database objects. When I say database objects, that can be either table or index or sequence, views, anything. Data dictionary will store the DBA database objects. Okay, now remaining components are there. Shared this server result cache. Once the result is done, suppose SQL queries are storing here, it will fetch the result from result cache. Results will be storing here like that. There are some other optional. There is something called ILM bitmap tables, latches, ASH. These and all not required as of now. So this is the optional. So you focus on mainly library cache and data dictionary cache. This is the components of shared pool. Now coming to the large pool, okay? Large pool. Large pool is the area where the user SQL's flows, okay? We have a order, right? To get the query of particular result. Whenever we give the one query, we are getting the result, but in background there is some order, right? First it should go to some particular component, then it have to check, then it has to pass to the next step, then it has some few checks, then it has to go to the next. So it is a sequence of, it's an order of executing a SQL statements. When I say large pool, you will be having the there are some kind of components where it will follows the executable sequence. Okay. So how basic SQL will flow? How basic SQL will flow? So suppose if we get the any SQL statement from the dedicated server, the process will go like this. Okay. I'll explain in the diagram. As from the client application, it will send to the request to the database. There is some background process called dispatcher. It will places the request in request queue. It will places the request in request queue. Then this server process. When I say server process, what is the server process? PGA, right? So PGA picks up this particular request. PGA picks up from this particular request, and it will place through the response queue. It will place through the response queue. And this response queue again will sends back to the dispatcher. The dispatcher will return results to the client. This dispatcher will results to the client. This is the flow of SQL statement. Any SQL statement. It will send to the request. The dispatcher will collect the request, and it will place one request queue which is located in large pool. So it's communicating with large pool. And again, this request queue will allocate one shared server process, which is nothing but our PGA. It will retrieve the data from database. It will retrieve either from the database or from the any cache memory. And I say cache memory, DB buffer cache, that might be DB buffer cache, or the result server. These and all we have talked about, right? Share library cache, server results cache. Wherever the results available, it will fetch. The results might be available in cache data. If there is no data from cache, it will load from the database. Then again, it will send to the response queue, which is again under the large pool. This response queue will again gives the results to the dispatcher. This dispatcher will returns the response to the client. Do you understood the flow? So I've explained that particular thing in theoretically here. So you guys please go through this. This is on the page number 12. Okay. So you place the diagram one side in one hand and you read these sentences. You able to understand much better. Okay. Any doubts in this? Okay. Going to the next. Going to the next, where we talks about the DB buffer cache. What is a DB buffer cache? So DB buffer cache is the information or data where it will store from the either user or from the database. Okay, it can be have the actually in DB buffer cache we will be having the buffer pools. It's the storage of 2K, 4K, 16K, 32K. You no need to, worry about much on this. I'm explaining theoretically, but it's not again interview part. You just say DB buffer cache will store the information about the database. That's all. So it will stores the data from users when they are inserting the data, or it will reads the data from database when user is requesting to retrieve the data. That's all. How it will store or how it will retrieve? It will store in the form of buffer pools. It will store in the form of buffer pools. Wait a second, guys. Just allow me a minute. Hello, sorry about that, guys. Okay. Now, so the data will store in the form of buffer pools. When I say buffer pools, it's a general, in general, those are the blocks. Okay. Those are the blocks. That particular block size can be either 2K or 4K, 16K, 32K. The database will store in the form of blocks. We can call it as a DB blocks. Okay. Now that's the information about the database buffer cache. You don't need to worry about all this theory. If you want, you can go through this. Now, database data files, we haven't gone through it. This is a physical file structure. We'll discuss this later. So you mainly focus till the page number 14, okay? Till page number 14, forget about the 15 and 16. Again, these are the table space we haven't discussed yet. 16, 17, 18, 19. Okay, you don't need to focus all these things. Again, they have explained about, I've explained about the PMON. Periodically scans and it will responsible to bring up the database. That's what I've written. These are the something process manager it is. Okay. Listener, I've explained it. Yes, Mon. So you mainly focus the till page number 14, guys. Okay. I think we have covered all the things, this background process, what this will do, everything we have covered in the previous slide itself. Log writer we have covered. Archiver, what it will do, we have covered. Recovery writer process, we have that's again some kind of just optional thing. Yeah, flashback is optional. Space management coordinate is optional again. So these are the things. You focus till 14, slide number 14. So you'll able to cover all the information which is regarding Oracle architecture. Okay, wait. Yeah. So when I say explain about Oracle database architecture, you make a practice, take a paper and pen, you draw this diagram. One user connects to the server process through the listener. Server process is nothing but PGA, and we have an instance and we have database. In database, we have the control files, data files, online read log files, and we have in instance, we have some SGA and some background process. So background process connectivity. I mean, from the SGA, from which component it will connect to the which files to the database. So you make a practice of this diagram. So you clearly understood this, right? So this is architecture of the database. When I say database, it's a combination of instance and database itself. In instance, it's a combination of memory structure and background process. When I say memory structures, it's a combination of SGA and PGA. We have some components in SGA. Those components are called shared pool, large pool, database buffer cache, redo log buffer cache, Java pool, stream pool. When I say PGA, we have UGA, user global area, and bitmap merge area, SQL work area. Those kind of components we will be having in PGA. So this is shareable. SGA is not shareable. I mean, PGA is dedicated. So for each client, one PGA will be allocated in dedicated server. We can make it as a shareable also. In the same way, SGA is shareable. We will be having only one SGA for the instance. And we have some background process. SMON, PMON, DB writer, log writer. DB writer writes and reads the data from DB buffer cache and loads into the data files. Log writer will read the data from log buffer and load it to the online redo log files. And there is a checkpoint which is consistently updating the SCN whenever the change happens or whenever the commit happens. It will update, it will generate one unique number and it will write into the control files and data files. And there is one more process called archiver, which will takes the backup of online redo log files to the archive redo logs. So basically archive logs are the backups of the online redo logs. We can maintain the database with or without enabling archive log mode. But if we enable, and if we maintain the database in archive log mode, it's a very useful in the recovery. We can recover the database up point in time. We will discuss about these recovery scenarios, backups and everything later, but just understanding purpose, you just make a note of archiver process. So any doubts or any questions in this particular diagram? Forget about these two icons. Anyone? So when I say memory structures, again, here are the SGAs and PGA. So how to see the background process? PS-EF grep. You can see some database background process using this particular query command. It's not a query, it's a command. What and all things we execute in OS level, these are called commands. What and all things we do executed from SQL prompt, this is a query. All right. So now I'm open for any questions and doubts. Okay. So I think everyone is clear with it. I hope, I assume. So please go through it and read the theory and try to make the understand. Since it's a very important topic, you will be having almost 30 to 50% of interactions in the architecture itself. Remaining everything else technical, we can answer it out. You should be strong enough. If you are putting 3 years of experience, you should be strong enough in Oracle architecture. So in following week, we'll start with the installation of our softwares. So the whole week will goes for installing the softwares, installing the Linux, and installing the database, and for we'll practice some basic
Linux
commands.
comments.
Basic Linux commands. Okay, I'll share the which and all commands are useful. So once your practice is done with Linux, we'll start with the database.
Okay.
Yes.
Basically, how many Linux commands are we gonna use in generally in like
Generally, I can say hardly for the basic purpose, hardly it might be up to 20 commands. That's all, 20 to 30.
okay. That
It's
would be in
just
real
LSF
time.
and
That
LRT.
would be,
Sorry.
that would be in real time too. Like
Yeah, that would be in real time too. Right. It's a kind. It's an. I can say whatever you managing in the Windows, right? You have
yeah,
to do it command through the commands in Linux. That's all.
yeah.
So in Windows, if I want to go back, I can directly click on the Oracle folder. Or if I want to create a new folder, I have to create the right click, then go to the new, I have to create the folder. This is how we work in Windows. But the same thing, we'll do it as a through the commands in Linux. So if I have to go back, I have to give the command. Okay. If I create a new folder, I have to give the command. So suppose if I want to know the current path where I'm in D local drive, Oracle folder and demo folder is there. Suppose if I go here, if I want to know the current path, pwd is the command. See, pwd present working directory. If I give this, it will give the path. If I want to see which and all files are available in this folder, simply I have to list this
ls-ltr.
yeah, right, like this. Okay, so if I want to go this particular any directory, I just cd change directory to downloads.
Okay.
So to see the again available files ls-ltr is nothing, totally zero. To know the what is the path which I'm currently working is pwd. You are in this location now. These are the kind of Linux commands we will be using. These are the
Got it.
basics, right?
Got it.
Okay, so we'll be practicing this. I'll be giving the list of commands what we use.
Most of the part lies around with architecture, right? Like
Right.
if you have grip over that, you
Right.
could easily manage.
Right. Architecture, and I'll explain the structure of the database. This is architecture, what we have gone through till
Yeah.
now. Later we'll see the structure. What is a logical structure? What is a physical structure of the database? Okay. So you will understand the which and all files required to maintain a database and everything, terminologies, everything.
Yeah, sure.
So these are the things. So I think I hope everyone is putting years of experience around 3 to 4, right?
Yeah.
Yeah, so we'll get the knowledge that is required to clear the interview for 3 to 4 years, guys. Okay.
Okay.
So apart from this, any questions? So I want any one of one laptop or any one of for the next class. So I'll start installing the softwares and downloading softwares in their laptop, any one of your laptops, because mine is already installed and one class is going on. So I simply can't delete this. Okay.
Okay, sure.
Yes.
So anyone please attend the class with one laptop, whoever having it.
Okay, sir.
So there's a requirement from me. So you can discuss any questions or any queries, any concerns over here. So what you guys are think you can make up to this course, right?
Yeah.
Or anyone wants to drop off, anyone feeling is difficulty?
No, sir.
Okay then. All right. So let's wind up for today. We'll meet on Monday again.
Okay, sir.
Okay. So guys, someone was asking to change the timings. Who was that? from 8 to 7. Someone was asking yesterday's in group.
He is Vinay, sir.
Vinay? Okay, are you okay with these timings? What is the issues you are facing with these timings? Because I'm making hard at least for this timing, you know. I'm hardly sleeping 4 to 5 hours and waking up 8.
Actually, he is also an employee, sir, working employee.
Okay,
And that's why he is asking for changing the time.
I think Vinay is on unmute, but he's not able to speak or what? Okay, we got the 2 charts. Okay, that's fine. Okay, we'll catch up on Monday at the same timings. Okay, 8 a.m.
Okay, sir.
So if any doubts while you are reading or anything, just in case of any doubts, just drop a ping.
Okay, sir. Once I will check.
Okay, fine. Thank you guys. Have a good day. Bye.
Bye, sir. Bye, bye.